Welcome to the Fed 3 build instructions. You can also find these instructions on the Hackaday link below. So I'm going to start out by reviewing the parts. The only custom part is this PCB. The files for that are also on the Hackaday. And then other than that, we use a range of parts, many from Adafruit and from other suppliers that you can find on the Hackaday link. You only need a few basic tools. You're going to need a soldering iron and solder. You're going to need some snips, a Phillips head screwdriver, a hot glue gun, and then for the end we're going to coat with this clear acrylic. So now we're going to go over assembling the electronics. You can find these instructions and pictures reviewing how to complete these steps on the Hackaday link, and then I'll also go over them in this video. So the first steps are that we're going to put all of the headers onto this PCB. The approach we've taken here is to use headers and use Adafruit breakout boards for most of the main components. So I'm using these low profile headers that are just a little bit smaller than the standard size, a little bit shorter in length. And the ones for the feather, that's the headers we're soldering on right now, come pre-cut. Some of the other ones, we buy these long strips and cut them, or if you want to be really fancy, you can find them cut exactly online, but they'll be specialized parts. We're now soldering on two headers that we cut that are for the motor driver. Tried to speed up some parts of the video. This is a little 5-pin header that we're going to attach the motor itself to. And finally, another 5-pin female header that we're going to attach a real-time clock breakout board to. We're now going to install the photo interrupters. These are small devices that contain an infrared LED on one side and an infrared receiver on the other. And these are what we're going to use for both detecting the nose pokes as well as detecting the pellets. So you can push them into the PCB. I'm going to put all three of them in, and then we're going to solder them into place. You want to be careful on these steps not to short anything. These pins are very close together, and make sure that the solder doesn't bridge across and short the pins to each other. We're then going to use snips to remove the excess wire. And here again, be careful as you're snipping them that you don't accidentally bend them such that they're shorting each other. Each of these photo interrupters, the LED on it is current limited with a resistor. We're going to use a 1 kilo ohm resistor, and there are places on the PCB to install 3 of them, one for each photo interrupter. Also be careful which side that you're installing these on. You can look at the photos on the Hackaday or watch the video, but basically everything is getting attached on the back side. We're currently looking at the front of the PCB. All of the hardware is being attached to the back of it. If you accidentally install it on the wrong side, it probably won't fit into the final device. We're now going to install a buzzer. This is a simple piezo buzzer that can be used for auditory feedback. And it actually doesn't matter which way in it goes. You can just install it in those across those two pins that say buzzer, and then solder it into place. Now I'm going to attach the screen. We're using a breakout board for these sharp memory displays. They're a very interesting display. They're extremely low power LCD because they get their low power because they have a memory effect that stays on the screen even when the power is off. We're using a 90-degree header. And if you look at on the PCB, there'll be markings that tell you which pins it should go on. So we're going to install that at a right angle, and screen is going to be visible from the outside of the FED. You may want to look at the photos on the Hackaday page to be sure that you have the pins lined up. We're now going to install a BNC output. This can be used for any type of synchronizing output. So we often set this that when the animal takes a pellet, we'll get a TTL pulse out of this. It's actually tied to an analog pin, so really you could program the FED to send any type of analog signal out of this BNC connector. And then finally we're going to put this NeoPixel strip, and this is actually quite the hardest part to solder. I'll explain how we've done it. We're going to first put solder on these pads, and I'm only going to put solder on the 5 that you're seeing here. I'm actually going to avoid putting solder on this bottom pad because in our board design, we put a via right next to that pad, and it's very easy to short it. Maybe that's something we'll update in another design, but as long as you keep solder away from that final pad, you should be okay. Then we're going to put solder on the NeoPixel strip itself on those same pads. So all the solder's already been put on there. We're just going to hold it in place and touch the soldering iron to the right side. A very fine tip soldering iron is helpful here. We're going to try to melt it enough that we hold it into place. We can then line up the left side. May want to make some small adjustments. And then I find that putting a little bit of extra solder, you can see it wicking under the NeoPixel. And that'll help bind to those solder pads on the bottom. And we're just going to use those 3. Again, we're going to avoid that bottom pad. We don't need it. And there's a chance of shorting to a via, which will make the NeoPixel not work. We're going to use 3 breakout boards from Adafruit. These are the Adafruit M0 ADA logger. This is the brains of the operation. It's both the microcontroller and it's also contains an SD reader-writer right on it. And that's how we're going to log data. So we're going to put these male headers onto it. They come, the ones it comes with are slightly too big, or one side of them slightly too big. So we're just going to snip that down. I find it easy to use a breakout board to position it, and that keeps everything in place while we solder these headers onto it. One of the reasons we chose to do these designs with headers is that if at a later point you decide that you want to take the FED apart, build something else with it, all of these boards are still usable. We haven't actually soldered them directly to the PCB, which might make them difficult to get off. The next board we're going to put headers on is this real-time clock. This real-time clock board will allow the Fed to remember the date and the time even when power is removed. So this was a weakness in Fed 2, that whenever we lost power, we'd actually lose the date and the time. For Fed 3, we put this extra real-time clock on there. The battery should last several years. So once you've flashed it once and set the time, even if the Fed completely runs out of batteries, you'll just charge it again, wake it up, and it'll have the correct time. Then the last part is a motor driver, which actually I already soldered the header pins onto. So we have these 3 pins. We're going to need an SD card. Pretty much any micro SD card will work. We haven't really found one that doesn't work. So we'll put that into the AdaLogger now. For the real-time clock, we're going to need this coin cell battery. And we'll also install that at this point. And now we can just push these onto the Fed PCB. And we've populated it. Again, if at a later point you have a different project, you may want to pull them off, and they're not damaged, they have headers. At this point we can flash the code. I recommend looking at the Hackaday. It'll tell you how to install the Arduino and what libraries you'll need before the code will flash. But you can download the 2 codes. One of them is going to set the clock, and one will actually run the Fed code. We double-click on the AdaLogger to enter a bootloader mode, which you'll see because of this breathing red light. And now we're going to use the Arduino IDE. We're going to check and make sure that the correct board is selected. This is the M0, Adafruit M0. And then we're also going to check that the right port is selected, and we can flash the first code, which is to set the clock. If this flashes correctly, you'll see the correct date and time. This is getting the date and time from the computer, so whatever the computer thinks is correct. You'll also see that the NeoPixel is working. We're now going to double click it again. So this is now set the real-time clock. We never need to set it again. We'll double click the AdaLogger, and now we're going to flash the Fed code. And this is the code that's going to run the pokes and run the pellet dispenser and do all the things that Fed does. So now if you take a look at the screen, you should see a little mouse running across. It's entering a few different modes. I can hold both the left and the right pokes to reset it. And we can do some various things, but basically I'm confirming that everything's working, and this is the hardware of Fed. It's largely complete at this point. So now we're going to assemble this hardware and put it into the 3D housing. We're going to add a couple more cables just to make things convenient. One of them is a little button that you saw me put on there. The other is an SD cable, a micro USB cable, that we just want to use this short extension wire to move that micro SD connector to the outside of the device. This will allow us to charge the device and flash the device from the outside. So I'm using some hot glue. I'll just hold that in place for a few seconds to make sure it hardens. And now we're going to install everything into the plastic, the 3D housing. We've printed these already. And the first step is that you can just push the entire device into the faceplate of the Fed. It should snap in. And then there are 2 threaded holes that you're going to use the screws to secure it in place. We're now going to attach the stepper motor. Stepper motor has a red wire, which is the ground, and that goes to the left side in the orientation that we're seeing here. So also the word ground is printed on the PCB. And then we'll just wrap up the extra cabling to keep it out of the way, and we're going to screw the motor into place. And this motor will end up underneath the pellet hopper. So there's one screw on each side. We're now ready to put FED into the main housing. So these two parts snap together. You may want to push a little bit cautiously, make sure everything's lined up, and then they'll snap into place. And they have little tabs inside that will hold them there. The screen has a little tab to hold it. You're going to want to push on it from the inside to make sure it engages that tab and comes across, gets in there straight. You'll notice if it's not in there correctly, and you can redo that step. We'll put this little pellet disc on. It should push snugly onto the motor. The pellet hopper is threaded, as is the lid. And then finally, we can add the battery. I'm taking a new one out of the bag here. This is a 2-cell LiPo battery. It'll provide FED with about 5 days of power in constant use, quite a lot more if you're using it intermittently. And then the power switch now allows you to stop and start, basically cut power to and from the battery. We're just going to push some of that wiring out of the way, and then there's a little cradle that'll snap the power switch in. There's 2 tabs to hold the battery securely so it doesn't bounce around in there. It takes a little bit of force, you'll get the battery secured in there, and then wrap up the final bit of cabling. And that's it. That's a FED 3.